Okay, word search. So given a m cross n grid of characters board and a string word, return true if the word exists in the grid. The word can be constructed from the letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same letters may not be used more than once. That means cyclic. It should not cross, I guess. Yeah. So we are given word A B double C E D. So A B double C E D. Got it. Neighboring cells. What is this? S double E. S double E. Okay, we can go back also. We can go forward also, back also. Can we go up? Yeah, maybe. Let's see. A B C B. A B C. What if B is here? Can we take it? Yes. How to form it? I think it's easy. We can do it recursively. So let's see how to write the recursive function. So if I say solve, I'm given the word. Okay. Let's see. So if I'm given a word and a grid, okay, so I can say how to find if this word exists inside this grid or not. Okay, so what do I need? I need which character I'm processing. So I think that index of the word. Got it. So if I'm on that index, so so if this is the word, I'm processing this index I. This is the word. Okay, I'm processing this index I. How? And it also depends. So I need to be at some position. So let's say x and y. X and y. So which character I'm processing, which location I'm currently at. Okay, so let's say I might have found one here, and currently I'm at this point. Okay, so if they match, okay, I should go to this point if and only if that characters match. So from here I need to check in all the 4 directions, right? All the 4 directions, or only 3 directions are possible? Yeah, because if I'm coming from here, no, we cannot use the same letter twice. Okay, so what if I have come from here, I came from here, I cannot go here, but can I go here? No. That means I need to remember the path also. Okay, so I should have a path. What is important so far? The path. I can say it is nothing but a set of pair of x and y, right? So which path I have taken so far, and from x and y I should be able to go in all the directions which are not in the path, right? Yeah, what is important so far? So which character I am processing currently, that means what is important is this: how many characters of this word I have processed so far, what is the path I have taken, and from here which location can I go. I should only go to that which is not inside my current path, right? So if I So this should change, it should keep on changing. Okay, these locations will be unique only, so I can delete once I go here. If from here word is not possible, then I should delete this, right, and then explore from here. Maybe this is possible, because yeah, I need to delete this. So from set I can do deletions. I think these three only. Yeah, let's write the code. These three only. Let's write the code. Okay. The class solution exists. Find if in this board this word exists or not. Okay, so int m, in rows m columns. Okay, we can say in his board how many rows are there. Okay, image board of 0 dot size. Is board always have some size? Yeah, at least one. So fine, we can write it. Now I need to find bool exist inside this board. Does a word exist? Okay, in an m I got. What is that sol function? What is that word? Okay, which character I'm processing? That is important. Let's write that sol bool sol which character I'm processing for that word. Okay, string word. String word, and at which location of the board I'm currently present, right, and this board also, which location of the board I'm currently present at, as well as the set of pair of integer to integer at the rate. What is the path I have taken so far? Yeah, so bool solve which character I'm processing of this word, and x and y where I'm standing in the board, in this board, and what is the path I have taken so far. Okay. If these two are equal, these two I should start from this path, x and y. Okay, that means I and x and y, this should be equal. Okay, so I should try from all the possible paths, right? So bool answer is false, and let's go to all the positions, all the possible positions, I less than an I plus plus. So if board of ij is equal to word of 0, that means if this is equal, we can try answer I can try from here that pros I that means this is equal, these two are equal. Okay, so 0, and which character of the board I need to pass the word also, word ij, and board and path. Okay, inside the path I need to insert, okay, every time there is a match it should be set of pair of integer to integer path dot insert what I have taken this I to j, ij index already. Okay, so bool false, go to all the rows or the columns if this is equal to word, if this is equal to this character, then inside the path push this ij and solve for other 0 word. I have processed till 0 index inside the word, and that was ij, board and path. Okay, if answer is true we can return true, otherwise we can return false. Return false. Okay, bool exists. This for this is f done, this is for exists. Okay, let's write the solve function. So we have nm ij word xyz. So I'm standing at xy and character is I. This is the board, this is the path I have taken so far. From here I can go in all the 4 directions. Okay, which directions? So let's say dx 1 minus 1 0 0 and dy of 4. Okay, 0 0 1 minus 1. Okay, go to all the 4 directions. Okay, 0 k less than 4 plus plus, so x1 is x plus dx of k, and y1 is y plus dy of k. So x1 y1 dx of k, y plus dy of k. So if x1, if can go to x1, can directly check if x1 greater than equal to 0 and x1 is less than n, and y1 is greater than equal to 0 and y1 is less than m, and x1 greater than equal to x1 less than n, y1 greater than equal to y1 less than m. And so if this is possible, this is inside, as well as this is not inside the path, and these two are matching, right? And path dot find of which thing, x1 y1 is equal to path dot end, and this happens, path dot find of x1 y1 is equal to path of end, that is it is not visited, it is not in the current path, and what, the characters should match, right? So the word at I plus 1. From I will be going to I plus 1. It should be equal to the matrix, that means board of x1 y1, if this is correct. Okay, what did I write? Let's write in Leetcode console only. What did I copy? Just board word and m. Goal answer is false for every row, every column. If this is word 0, if these two match, then I will start my search. Take a path, insert that IJ and go to solve. Answer is equal to solve. If that is possible, I think we can directly write. So if that is the case, we can return true. Otherwise it will keep on searching. So from here it is possible to find the word 0, word, IJ, board, path, then return true, otherwise finally it will return false anyways. Okay, or recurrence relation. Solve for I so let's try to go in all the 4 directions. K equal to 0 to 4, x1 y1, from x1 greater than equal to 0 and path dot find is, and this happens, and okay, these conditions, x1 it is inside my grid, and this does not exist in the path, and the character I am going to, word of I plus 1, is equal to board of x1 y1. The character I am going to I plus 1 is equal to this. That means I am going to a board. Okay, this is possible. Then we can go and solve for I plus 1 inside the word x1 y1, board and path. Okay, we need to insert it into the path dot insert. Okay, that means I have taken x1 y1 in my path, x1 y1. So what is the answer from here? Bool, it's possible. You can say exists, does exist. So bool exists is equal to solve. So what did I do? So from here I xy, I checked x1 y1. If from x1 y1 and I plus 1, if it is possible, then okay. If exists is true, that means yes, it is true. If exist is true, we can return true. Otherwise, let's try to, so that means if x1 y1, so it tries x1 y1 and it did not find that, what it should do, it should remove this path.erase. Here, what did I do? Okay, it is readable. So path bool exists. If exists, return true. If it does not exist, okay. So from I is a, okay. So from here I went here, okay. From here it is not possible. Then remove this from the path and try to find from here. If it is possible from here, that means it should return true. To here, it should return true. It should again return true. Let's say it was coming from here. I think, yeah, got it. So if it is possible, so I checked key. If I can go to this path, take this inside this, and if from there, from x1 y1, if it exists, then return true. If it does not exist, try another direction. So but before trying, we should delete this path.erase. What? Path.find x1 y1, whatever I have inserted, let's erase that. It will try another one. So by default it should return false, right? Because it is not possible. After trying everything, if it is not possible, okay, by trying all the 4 directions, if it did not return true, finally it should return false. What should be the base case? Base case is if I reach at the end, if I is equal to word dot length, ETH word dot length, I send return true, because here if I was not word dot length, so let's say I was word dot length -1, then it will try I is equal to word dot, so no, I is equal to word dot length, it will throw null pointer now, or index out of bound. So word, so I is equal to word dot length -1, or so if I am at the last character, that means at the last character it was equal, that means it should be here, it is equal to -1. It is equal to -1. If it is equal to -2, then it will equal to -1. It will be -1. Yeah, word of -1. If it matches, that means here I can return true. If somehow if I am able to reach at this location, it should be true. What else? Yeah, changing xy path, I think, yeah, that is only base case. Hmm. Hmm. Okay. Let's try. Okay, working. TLE 84, 85. Okay, at least it is working. Why it would keep TLE? Word. Hmm. I'm also directly returning it. Path is board is board, everything is by reference only. I'm not double counting anything. Can I not take this? Okay, I think we can remove this with boolean visited area also. Okay, so let's see. Path, in place of path we can write vector of vector what I'm writing, vector of integer, vector of integers path, a 2D grid. It should be a boolean, so I should mark that path vector of boolean path. Which path I have taken, so every path it will be marked as 1. Okay, we can say path of x1 y1 is equal to 1, initially it is 0 or true, and mark it false. And it will be a vector of path of n cross m. Everything is initialized as false, so vector of integer or boolean path n cross m false, path of I is equal to true. Creating a new one, mark it as true and pass the path. Okay, here we are taking it like this. So okay, so path of x1 y1 is equal to, so path of x1 y1 is equal to false or negation, this we can negate it. So if it is not taken in the path, then take it in the path, and if the answer does not exist from here, remove it from the path. Okay, I think this should work if no compilation. Expression is not assignable. Which one? Okay, it is equal to path of x1 y1. What did I do wrong? Boolean. Okay, why did I write int here? It is bool now. Yeah, about. Okay, I think it was easy. You just need a simple backtracking. Try all the possible paths. If answer exists in that path from that location, fine. Otherwise, try different by removing this. try different path by removing this. If after trying every path it does not exist, then by default it will be false. This was okay, got it.